some resources that you can also use in Course Compass. They do have a study plan out there which has extra homework questions that you can do just for practice. They won't count towards your homework grade though. They also have their own video lectures that are done mostly by the author of the book. They have some animations and applets that sometimes people find helpful. And then when you're actually doing your homework, there are a bunch of buttons on the right side of the homework problems that you can use. There's one called Help Me Solve This, which will take you through the problem step by step. There's one that says Show an Example. There are other ones that take you back to the videos from the publisher and animations. And then there's another one that says Ask My Instructor. And if you click on that one, it will actually send me an email. It will show me which problem you were working on, and you can write in there and tell me what it is that you need help with, and then I can email you back. Here's what the study plan looks like. It just goes through different chapters, and you can click on different sections and find different practice problems to do. Here's some other stuff from Course Compass, the multimedia library that has pieces of the textbook, it has videos, all this other stuff. So in Chapter 1, just so you know, we're only covering basically 3 topics in here. We're going to skip a whole bunch of the stuff that's in there. So the first topic we'll cover today is going to be levels of measurement, and then we'll also talk a little bit about misuses of statistics, and we'll talk about a little bit also about working with percentages, because that's something you'll have to do quite a bit in this class. So first of all is types of data. You can have qualitative data, which is just basically a category or some kind of attribute about the data. So if you have qualitative data, that means you can separate it into categories. This might be something like male or female, or survey answers, or rankings of football teams, that kind of thing. It can have a numerical value, or it might not. For qualitative data, we have 2 levels of measurement. The first one is nominal. This just means that the data is only a name, an identifier, a category, and it's something that can't be arranged in order. So for example, if you have some survey responses, these could be yes, no, or undecided. Those are not anything that you could put in an order that would make any sense. The other level of measurement for qualitative data is the ordinal level. And this means that you can arrange it in some kind of order, but you can't really tell by the categories what the actual differences between the data values are. So for example, if you're talking about your grades in a course, if you just say A, B, C, D, or F, you could definitely put those in order from highest to lowest, but that wouldn't tell you the difference between, say, if you got an A and someone else got a B, that wouldn't tell you actually how many percentage points your grades differed by. Then we have quantitative data, and this is always going to be numbers, and it represents counts, measurements, those kind of things. So one example would be the weights of supermodels. And for this one also, we have 2 levels of measurement. The first one is the interval level, and this is kind of like the ordinal level that we had before, only in this one we can tell the difference between 2 data values. So for example, if we had time in years, we could tell the difference between the year 1000 and the year 2000. That would be 1000 years. But for the interval level of measurement, there's no natural zero starting point. And also, if you divide one value by another, that ratio doesn't make any sense. So for example, with time values, the year 0 wouldn't be a natural starting point, because you could actually go back farther than that. It doesn't represent no time. And also, if you take a ratio of the years 2000 and 1000, that would give you 2, but that wouldn't really have any meaning. The other level of measurement is ratio level, and this one is like the interval level, only it has the 2 properties that the interval level didn't have. So it does have a natural zero starting point, and if you divide one value by the other, the ratios are actually meaningful. So one example of this that comes up a lot is prices of things. So for example, if you take the price of a textbook, 0 would be a natural zero starting point, because that represents no cost at all. And if you looked at a $50 textbook versus a $25 textbook, you could divide the 50 by the 25, get 2, and that would tell you that the $50 textbook costs twice as much. So that ratio actually has a meaning in this case. So here's a summary of the 2 types of data overall, the qualitative and the quantitative, and then the 4 levels of measurement. So nominal and ordinal go with qualitative data, and interval and ratio go with quantitative data. Okay, now we're going to talk a little bit about misuses of statistics. And I'm only going to talk about a couple of these. They have a bunch more in the book if you want to go back and look at them. That's up to you. The biggest one we're going to talk about is something called a voluntary response sample, or a self-selected sample. This is one, and we see this all over the place, where the respondents decide whether to be included in the survey or not. And the problem with this type of sample is that the people who do respond tend to be people with strong opinions about the issues. So, for example, if you see a survey in a newspaper or a magazine where either the respondents have to visit a website, or they have to call an 800 number, or they have to mail something in to participate in the survey, that would be a voluntary response sample, because they're choosing whether to respond or not. And you probably know from looking at these kind of things, you're not going to take the time and the effort to respond to something like this unless it's an issue that you really feel strongly about. So we do see these all over the place, but just keep in mind that the results from these type of surveys don't really tell you much about what the general population thinks about an issue. Okay, another thing we can talk about just a little bit is small samples. But when we talk about small samples, we're talking about really small samples, like 5 or 3. It's an easy misconception to think that just because a sample is small compared to the population size, that it's not a good sample, but that's actually not true. So for right now, you'll just have to trust me, and we'll only consider a sample to be too small if it has less than 30 members. This is another very common misuse of statistics, and this is misleading graphs. For example, in this one on the left, notice that it starts down here at 0 for the vertical axis, and you can see the 2 values here pretty easily. This one on the right starts at 30,000, and notice how different it makes the 2 values look. It makes the Nevada value look so much smaller than the California value when it really isn't. So in this case, the one on the right is misleading, the one on the left is not. Okay, another thing we see quite a bit is in survey questions, we see loaded questions. And this means that the words that are used are emotionally loaded somehow, and it's trying to get a specific response out of people. So for example, if we're talking about gun control laws, we say, do you believe that gun control laws which restrict the ability of Americans to protect their families should be eliminated? That part in the red is loaded because it's talking about Americans being able to protect their families. That's going to get a different response than if they didn't put that part in there. If they just said, do you believe that gun control laws should be eliminated, that would get a slightly different response than if they put the loaded words in there. And the same thing on the second one with big oil companies. That's kind of a loaded term also. Okay, one more misuse of statistics is, this is called missing data. And this means that the survey or the study was conducted so that big portions of the population are not represented. So for example, if a poll is conducted by calling phone numbers from 10 major metropolitan areas, then really the only population that this represents is people in those major metropolitan areas. That leaves out a lot of parts of the country. Okay, here's a little example of an article, and this is about a poll conducted by a website. This is about parents concerned about video games. And if you notice, they have 2 different polls that they're talking about here. If you think about how these surveys were conducted, here's the website, the What They Play website. And even in order to know that this was there, you would have to be probably a parent that was concerned about video games, even to find this website. And then for someone to go on and actually respond to the survey questions, again, they would have to be someone who was really concerned about this issue. So this would definitely be a voluntary response sample. And again, just keep in mind that the results from this don't necessarily represent the whole population. Okay, and finally from this chapter, working with percentages. This is the part that where we actually have to do some math. 4 things in working with percentages. First, if you want to convert from percent to decimal form, you have to move the decimal point 2 places to the left. And in the next slide, I'll do some examples here. If you want to go backwards from decimal to percent form, then you have to move the decimal point 2 places to the right. If you want to convert from a fraction to a percentage, divide the number of parts by the total, or in other words, divide the numerator by the denominator. This will give you a decimal, and then you have to convert it to a percentage, again, by moving the decimal point 2 places to the right. And finally, if you want to find a number that corresponds to a certain percentage, convert the percent to decimal form and then multiply the decimal by the total. So here's some examples. First of all, we're going to convert 8.9% to decimal form. And I'll warn you, it's really hard to write on this whiteboard, so I'll do my best to make it readable. Okay, so we're going to have 8.9. So we have 8.9, and to convert this to a decimal form, we're going to move the decimal point 2 places to the left. So it's going to go right there. We have to put a 0 in there for a placeholder. 8.9% in decimal form is 0.089. Okay, then if we're converting 0.56 to a percentage, now if we're going from decimal to percent, we want to move the decimal point the other way. So we want to move it to the right 2 places, which gives us 56%. That one got away from me. Okay, so we've got 56%. Okay, then if we have 18 out of 60 people surveyed that responded to a survey question with a yes, we want to know what percentage that is. That means we're going to take the 18, divide by the 60, and if you divide this, and please feel free to use your calculator for any calculations in this class. If you divide this, you're going to end up with 0.3. Now, if we want to convert that to a percentage, we're going to move the decimal point to the right 2 places, so that's going to give us 30%. Okay, and finally, if we have 8% of 300 people surveyed that answered yes to a survey question, we want to know how many people that is, the 8%. Then first we have to convert the 8% to a decimal. So we're going to take the decimal point, which is after the 8, and move it over to the left 2 places. That gives us 0.08. We're going to take that times the 300. So we just convert the percent to a decimal, and then we multiply it by our total. And if you multiply 0.08 times 300, you end up with 24. So that means that 24 people answered yes.